How are you? I hope you're doing well and keeping safe. In this video, I take you through Lab 3.2 on configuring STP, spanning tree. So about this lab, on a switched Ethernet network, redundant links are used to implement backup and therefore enhance network reliability. However, redundant links may produce loops leading to broadcast storms, two problems, and unstable MAC address tables. These will deteriorate or even interrupt communications in your network. So to prevent loops, IEEE introduced STP. STP is defined in IEEE 802.1d standard, and it has evolved to rapid spanning tree and multiple spanning tree. So in this lab activity, you will learn the basic STP configuration and understand its principles and some features of RSTP. Objectives: learn how to enable and disable STP, learn how to change the STP mode of a switch, how to change bridge priorities in order to control root bridge election, how to change port priorities in order to control the election of the root port and designated port, how to change port costs so that you can control again the election of who becomes the root, who becomes the designated port, and also learn how to configure edge ports when we are using RSTP. So learn how to enable and disable RSTP. So the scenario here is a company needs to deploy redundant links on its layer 2 switched network to improve network reliability. In the meantime, the company also needs to deploy STP to prevent redundant links from forming loops, causing broadcast storms and MAC address flapping. So this is the topology. We have four switches: switch 1, switch 2, switch 3, and switch 4. You can, for example, think of this switches here, S1 and S2, as being on the aggregation layer. Then maybe S3 and S4 as access switches. Normally, when we configure, yeah. So let's the configuration roadmap. We will enable STP, and then we'll change the bridge priorities, then port parameters like the cost. Then we will also change the mode to RSTP and configure an edge port. So we will begin from step number 2 to enable STP. So enable STP globally. The command to do that is STP enable. You have to be on system view. Now, let me go here. I haven't done any configuration on these switches, but let me do a data capture here, for example. Let me do a data capture there as an example. Okay, so if I do a data capture there, you can already see that S1 and S2 are exchanging STP BPDUs. You can see, we can just open up one of them, and indeed you can see we have the header. So you can see, for example, the PVI, protocol version identifier, is multiple spanning tree. So this one is using MSTP. So MSTP by default is enabled to run on Huawei switches. MSTP. So you can see the BPDU type, for example, the value there. You can see the flags. You can also see the root identifier that identifies the root path cost, the bridge identifier, port identifier. So all those fields that we looked at: message age, maximum age, halo time, forward delay. So all those fields we looked at when we were learning about the STP BPDU. All of them are there. Okay, so let me just close this. Then we can continue. Okay, so let's enable STP just as a matter of learning how to do it. So you need to be on system view. Then you type STP enable. So that is what we call enabling STP on the global view. So system view on S2, STP enable, enter. On S3, system view, STP enable. And finally on S4, system view, STP enable. Okay. So after we are done with that, we can use the command display STP in order to display the spanning tree status. So let's do that, for example, on S1. Okay, so on S1 here, we can use the command display STP. Now we have quite some information here, but one of them is the Stp bridge. This is the bridge ID of this particular switch. So you can see by default, the bridge priority is 32,768. Then this is the MAC address of that particular switch or bridge. The other bit that I want to show you is this one here, this one, syst root. So this shows you who's the root bridge. Who's the root bridge? So it is the bridge ID of the root. So if it's the same as this one, like it is on this example, it means this person is the root. This person is the root. So switch 1 is our root in this particular example. Okay. Other than that, this command will also show you the individual interfaces that are participating, for example, on STP. So for example, this one is on downstate G001 because we've not used it on S1. So it's not sending BPDU packets. So you can see that this is a disabled port, but you can also see information such as the port priority and the port cost and the standard that it's using. So for example, this one is using the Huawei default .1T. You can also see, for example, the designated port on this particular switch. Okay, so let me just do Control C to get out of this list. Then you go ahead and check. So other than that, we also have another command. This command is called display Stp Brief. So this command is used to show you the ports that are participating in STP, the role, the STP role that they are currently in, STP state. So those three. So let's do that so that we can try and understand the tree that has been generated in this particular case. Okay, so we can do that on all the switches. So display Stp Brief like that. So when we do that, we can indeed see that all ports on this particular switch, have the role of designated, meaning that this switch is the root bridge, because on the root bridge, all the interfaces assume the role of the designated ports, so that they can be able to send BPDUs to downstream switches. Designated ports, just like root ports, will always be on the forwarding state. We have not enabled any STP protection. If we had done it, it will show. STP protection is to kind of escaping my mind. But when you don't want a hacker to send bogus STP packets, if they send, then it's detected and assumed. Because if they send a BPDU that has a better a priority, we know that it will cause network flapping because election will have to occur again. So STP provides some kind of protection against such kind of hacks. Okay, so we can also do the same. So at this particular point, I think let's just label that this guy here is our root. This guy is our root. We can also label that this interface is designated. Let me put it here. So that one is designated. This one is also designated. Designated. This one, G0014 and S1 is also designated. 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 Okay. So this one here is also designated. So all the interfaces of the root is designated. So let's look at S2 using the same command. So display Stp Br for brief. Okay, so this one 0010 that is connecting to the root bridge is the root. So let's just label that so that you can be able to understand how STP functions. So this is our root 10. Then 11 has been blocked. 11 has been blocked, so it's alternate. 13 has been blocked, and 14 is designated. So 14 designated. 14 is designated. 13 is alternate, so it has been blocked. Alternate. We want to see how the tree looks like here. And 11 is also alternate. Has also been blocked. Okay, so let's go to S3 and have a look using the same command. Display Stp Br. So on S3, the root is G001 as it is right now. So let's label that. Then the other two are designated and are on forwarding. Oh, I just failed to state this STP state. If it's alternate, then it's on blocking. Blocking state is also known as discarding. So on discarding, it cannot be able to forward data, cannot be able to learn MAC addresses, but can still receive BPDUs. If you want to really know that it still receives BPDUs, we can just do a data capture, for example, here on 13. State data capture. So you can see that indeed on that particular interface, we are still able to receive BPDUs. We are still able to receive BPDUs. Okay. So don't forget that even ports that are on discarding state will receive BPDUs in order to monitor topology change. Okay. Next thing will be to check S3. We had already done that. So we have the root, which is G001. And then the others are designated. So this one is the root port. So R, the others, both of them are designated. So D and D. Okay. So G002, G003 designated. Okay, so let's do what now? Let's look at S4. So display STP brief. So G001 is the root on S4. The others have been blocked, alternate. So this one is the designated. The rest, alternate, alternate, alternate. So you can see, oh, sorry. This is not supposed to be, this is supposed to be root. That is the root, not designated. That's the root. Okay, so you can see from this diagram, from this topology, you can actually see the root. You can actually see the tree. Sorry. You can see the tree is like this. The tree is like that. The tree is like that. Otherwise, this line has been blocked. This line has been blocked. And this line has been blocked. Therefore, we are not going to have any loop. We are not going to have any loop in this kind. We are not going to have any loop. So that's how STP works in order to ensure that we don't have loops in our network. Okay. So based on the information that we just displayed, you can see this might differ from what you have or from what we have, but I think I have already demonstrated this on what we have just done. So step number 3, we are supposed to modify the device parameter to make S1 the root bridge and S2 the secondary root bridge. Why do we need to do this? Sometimes on the network, we want the switch with higher capabilities or high performance, and that is higher on the network hierarchy. We want it to be the root bridge. So that's why sometimes we use this command, stp root primary, to make a particular switch the root bridge. When you configure a switch with this command, then the switch priority changes to 0, and that particular priority cannot be changed using the STP priority command. Similarly, if you choose it to be the secondary, and then it will have a priority of 4096, and that priority can't also be changed. So we want to make S1 the primary, and S2 we want to make it the secondary. So let's do that. And what is very important there, of course, again, is most of the time we want to make the switches on the higher hierarchy as the root and as the secondary. So for example, if this is the aggregation layer, then this is where really we choose or we place the root bridge and the secondary root bridge. Otherwise, on the access layer, we already are aware that we configure STP between the aggregation layer switches and the access layer. So it's not very advisable. Even if you look at how data flows on your network, it's not advisable for you to make access layer switches as the root. Okay. So let's make switch 1. So you have to be on system view. Then you do STP. Sorry, I'm not able to type. Okay, sorry about that. So you do STP root primary, like that. Let me first of all do a question mark here, complete help, so it can only be primary or secondary. So primary, enter. Then we do the same for S2, so STP root secondary, enter, like that. Okay, so if we display the details here, display STP. So when you do that, you can see that the priority, the bridge priority for this switch has changed to 0. It has changed to 0. Here you can see that indeed this switch is the root bridge. This switch is a root bridge because the MAC address here is the same as this one. So this one is the root bridge. Then we can see that the root bridge type is primary root, because that is what we have used. So let's do the same, for example, here on S2, display STP. So we can see that the default priority has changed, and now this one is the secondary. It has the bridge priority of 4096. We can see that the sysd root or the root bridge is this one with a priority of 0. We can also see that this one is the secondary root bridge, secondary root bridge. Okay. Is there anything? Okay, so the next thing we're supposed to do is to display brief STP status information on all the devices, so that we can be able to see how the topology or the STP tree has changed. But in our case, S1 was the root bridge anyway, so nothing much would have changed. So I'll skip that particular step. Okay, so step number 4, we modify device parameters to make G002 on S4 the root port. To make that the root port. Okay, on S4. So okay. So what we want to do here on S4, we want to make it G003 make G002. Okay, G002. So yeah, we want to make this one here. We want to make this one the root. Right now, G001 is the root, so we want to make this one the root. Okay, so to do that, the first thing we need to check is the RPC. We need to check the RPC for G001 from the root. So we need to type display STP. Display STP. Okay, so if we go to G001, we can see it here, port 1. We can see that it's in forwarding state. We can see that it's the root port. The priority is 128, but most importantly, we can see that it's using the .1t, cost calculation, port cost calculation method, and we can also see that the cost is 20. We can also see that the cost is 20,000. Somewhere else where you see the cost, this particular cost is here, where you see the root bridge. The root bridge, then the next thing you get is the RPC. So this one here, 20,000. So the root path cost to the root, so it's 20,000 for the root port. 20,000. So if we want G002, let me just do enter until we get to the next G002. Okay, so if we want G002, this one, to be our root port, we need to configure a cost that is lower, than the current cost. So we can see for now this port is on discarding state, and the port role is an alternate port. Okay, so if for this gigabit Ethernet G001 the cost was 20,000, then for G002 it's going to be, because it has to go like this, for G002 it's going to be, it's going to be this one, 20,000, that 20 plus this 20, so it's going to be 40,000. This is going to be 40,000 because the cost here is 20,000. The cost here is 20,000. So it's going to be 40,000. So for us to have G002 as the root port, we need to configure G001 with a cost that is higher than 40,000. So for example, 50,000. So let's do that. How to configure the cost of a particular port? Control C to get out of this list. But let me just press enter so that you see that. You can see details of every port. So right now you can see this one is Gigabit Ethernet 003. So every port. So it's a very long list. But let me just do Control C to get out of that. Okay. So to configure the STP port cost, you go into the particular port, so 001. So we want to give it a higher cost. So STP cost, then question mark. You can see you can give it a value between that range. So we want to give it 50,000 because 50,000 is higher than 40,000. So once we do that, we can quit. Then you can see we can do display Stp Brief. So when you do display Stp Brief, you can see that our topology has now changed. G002 is now the root port, and G001 has been blocked. It's now on discarding states. So that is how we change the cost of a particular interface, so that we can dictate who becomes then the root port. Okay. So, the topology now will look something like this, because now G002 is our root port. So the tree will now look like this, as you can see. It will look like that. Okay. So let's now change the spanning tree mode to RSTP on all the switches. To do that, use the command stp mode RSTP. So let's begin here on S1. So stp mode question mark. So you can see that those are the three STP modes. By default, MSTP is used. So we started with STP. We want now to change to RSTP. Okay, so enter. We also go here. Enter. We go here. You have to be on system view. Enter. Then finally on S4, enter. Okay. So after we've done that, we can display STP, for example, on S1, so that we can see the mode that is being used. We look at that like that. Otherwise, everything else will remain the same, like the topology, for example. So if we go to S1 here and we do display STP, we can see that the mode is RSTP. So that's where you check the STP mode that is being used. Okay, so let's go to step number 6. We now want to configure edge ports. We know RSTP introduces two new port roles. That is the backup port and the edge port. So the edge port is used to connect to end devices or to terminals. So we want to configure G0010 all the way to 24 of S3 as edge ports. So to do that, instead of going into individual interfaces one by one and configuring them individually as edge ports, using this command stp edged hyphen port space enable, instead of configuring them individually, then we can use this command interface range gigabit ethernet 0/0/10 to gigabit ethernet 0/0/24. So that creates what we call a port group. And now we can be able to configure that group. So whatever command that we enter in that group will be executed on all the ports. The system will automatically execute the commands on all ports in that particular group. So I'm glad that this was introduced, because this is one of the questions that one of my students had asked me when I was training HCI R&S. So how do you configure multiple ports at the same time? So this is very interesting. So you use the command interface range. So let's do that on S3, remember. So we are doing that on S3 because S3 is an access switch. So from 10 all the way to 24. Let's just see, do we have 24 interfaces? Yes, G0024. So or from 10 all this to 24. We want to configure them as edge ports. Okay, so can come to S3 here, then use the command interface range G0/0/10 to G0/0/24. Enter. Oh, good. Okay, on the on the lab they said some of the switches might not support this particular R question mark nothing. So I think this is one of the switches that does not support the interface range command. It does not support the interface range command. So for this switch you have to configure one by one. So I'll just configure maybe 10, then you can do the rest. Okay, so int G0/0/10 STP edged port enable, just that way. So if you do display this, you can see that indeed you have enabled this interface as an edge port. Okay. STP. So if we go to 10, let me see. Okay. Oh, okay. So I think it's just a disabled port, the port role. I thought it will write a edged ports. Maybe because we have not because the port is disconnected, that's why we're having that. But I'm challenging you, just connect this port to an end device and see whether that status is going to change. Oh, you can see it here. Port edged, enabled. For the others, for example, for 9, do we have port edged disabled? So that's how you can confirm that. Okay. Display STP interface G0/0/10. So that's how you can also display just details of a single port. If you want to confirm, for example, if you want to confirm the details of a particular interface, you can use the command display STP int and then the name and the number of the interface. So ladies and gentlemen, thank you very much for your time. Please walk through the verification, this verification part, so that you can be able to understand this particular lab better. Otherwise, thank you for your time. I hope you've understood how to configure STP on Huawei switches. Asanteni sana.